Researchers effectively managed to retrieve DNA from a collection of sediment blocks prepared as long as 40 years ago from sites in Europe, Africa, Asia, and North America. A team of researchers from Leipzig's Max Planck Institute for Evolutionary Anthropology recently released a study in which they investigated DNA preservation in sediment on a microscopic level. They found DNA samples of ancient humans from the retrieved samples of archaeological sediments. Researchers employed undisturbed chunks of sediment collected from archaeological sites and then submerged in synthetic plastic like polyester resin for the study, which was published in the Proceedings of the National Academy of Sciences journal. Researchers effectively managed to retrieve DNA from a collection of sediment blocks prepared as long as 40 years ago from sites in Europe, Africa, Asia, and North America. The work ushers in a new age of ancient DNA investigations, allowing for the exploration of areas that have long been inaccessible to a massive untapped repository of genetic information. The researchers utilized sediment blocks from Denisova Cave, a location in the Altai Mountains of south-central Siberia, where ancient DNA from Neanderthals, Denisovans, and modern humans has been recovered, and discovered that microscopic organic particles produced more DNA than silt collected randomly. The method described in the study allows for extremely localized micro-scale sediment sampling for DNA studies and demonstrates that ancient DNA, ADNA, is not equally distributed in the sediment and that certain sediment characteristics are more favorable to ancient DNA preservation than others. As reported by Science Daily, Mike Morley of Australia's Flinders University, who led part of the geoarchaeological investigations, said, "This study is a big step closer to understand precisely where and under what conditions ancient DNA is preserved in sediments." Furthermore, Diendo Masolani, the study's lead author, was able to retrieve significant amounts of Neanderthal DNA from only a few milligrams of sediment. He was able to determine the gender of the people who left their DNA behind and demonstrated that they belonged to a group connected to a Neanderthal whose genome had previously been reassembled from a bone fragment taken in the cave.